In this video, we'll be looking at polygons and their interiors. The word polygon is a combination of two Greek words, poly, which means many, and gon, which means angle, so many angles. Some examples of polygons that we see everywhere are soccer balls. The pentagon and the hexagons that make them up would form polygons. Road signs, you got your yield sign, your stop sign, other signs, speed limit. Gazebos, they make up, you can see all the polygons inside, the rectangle here in front. Stained glass, you can of course see all the polygons in there. And finally, quilts. There's lots of different patterns inside of quilts. A polygon, the definition, is a closed plane figure with at least three sides that are segments. The first picture would be a polygon because it's closed and it doesn't overlap. The second picture would not be because of this open space making it not closed. The third figure also would not be a polygon because it intersects and overlaps. A convex polygon has no diagonal with points outside the polygon. So if I connect any two vertices, the diagonal will stay inside of the polygon. A concave polygon has at least one diagonal with points outside the polygon. So if I connect W to M, that diagonal, it goes outside of the polygon. It's also important to note that this can have diagonals that are inside, but a concave will have at least one that's outside. So is the figure a polygon? If so, is it concave or convex? Take a second, try to think through what it would be. The first figure would be a polygon, so yes, but it would be concave because you notice if you connect your diagonal from here to here, there are points outside of the polygon. The second figure would not be a polygon because of this section right here. And the third figure would be a polygon, and no matter what diagonals I connect, you'll notice that they never, I'm sorry I'm not drawing very straight here, but they never leave the polygon, so that would be convex. All right, let's talk about regular polygons, equilateral, and equiangular for a second. An equilateral polygon has all sides congruent, hence equilateral. It's very similar to the equilateral triangle, except for now it can have more than just three sides. An equiangular polygon has all angles that are congruent. If you remember when we learned about triangles, if it was equilateral, it was also equiangular and vice versa. This is not true necessarily for other polygons. You can have other shapes that have the same length for sides, but the angles are different. But when they both are equiangular and equilateral, they are called a regular polygon. So a regular polygon has all sides congruent and all angles congruent. So let's look here for a second at our shapes. This would be regular because all the sides are the same and all the angles are the same. This would not be regular, even though all the sides look they're the same. The angles, you can see this big angle here is not the same as this angle here. Not regular, regular, not regular, finally, not regular.